Let's take a look at these problems. The first one we got 1/2 is equal to 2 to the x plus 3 power. Well, I can rewrite the 2 in the denominator as 2 over 1, or 1 over 2 to the first power. Because if I were to put an exponent on it, you can always put a 1. And then we have a property. It says we can take 2 to the first, move it up on top, and it becomes 2 to the negative 1. You can always move anything opposite of where it's at in a fraction. The sign of the exponent changes. Now from our equality of exponents, it says if both of these are 2 to a power, then you can think of it as crossing the 2's out and setting the exponents equal to each other. So we've got negative 1 is equal to x plus 3. Then I take 3 over, becomes a negative 3, and we end up with x is equal to negative 4. Now our second problem, we have e to the 2x plus 1 is equal to 10. Now this, we obviously can't rewrite 10 as e to a power, so we have to use a different process for solving this. And this is our general steps for solving an exponential equation. And our first step is to get the part with the variable and the exponent by itself on one side. And that's true. This is e to the power. There's nothing in front of it, nothing after it. Just simply have e to that power. Our second step, we take natural log of both sides. It's got natural log of e to the 2x plus 1 is equal to natural log of 10. Now our third step is to use properties of logs to get the variable out of the exponent. In this case, natural log and e cancel each other away. They always do. So that gives us 2x plus 1. Now I'm still trying to get x by itself, so I'll take the 1 over. So we got 2x is equal to negative 1 plus natural log of 10. And then divide both sides by 2. And we get negative 1 plus natural log of 10 divided by 2. Now anytime you put anything in your calculator, if you have more than a single number, or a single variable, a single anything, on top or bottom, numerator or denominator, you want to put parentheses around it. So on this one, as soon as my calculator comes up, okay, put a beginning parentheses and negative 1 plus natural log of 10, closing parentheses on natural log, closing parentheses on numerator, divided by 2. And we get x is equal to 0.65, and they probably rounded to 1 decimal place if I had to guess. That's interesting. I rounded correctly. Let me double check myself. Natural log of both sides, those cancel. 2x plus 1, take that over, divide by 2. Negative 1 plus natural log of 10, divided by 2. Yeah. Let me just double check. E caret, and then 2 times my previous answer. So do the answer in the calculator, do second, and then your negative. Plus 1. Then, yeah. They just rounded wrong. It should be 0.7, but anyway, the one that's closest to is C. Okay, this one right here. It says if 10,000 is invested at 8% compounded monthly, how is the investment worth? What is the investment worth after 5 years? Choose the correct answer. Doesn't say anything about continuous. It says compounded monthly, which means it's going to be this formula right here. Now, A is your ending amount, which is what they're asking for. It says 10,000 is invested. That's our P. That's our principal. So P is 10,000. Now, they tell us the rate is 8%, and you put that in decimal form, so that'll be the 0.08. Now, N is the number of times compounded per year. And it tells us it's compounded monthly, which means monthly implies it's compounded 12 times per year. And T is a number of years after 5 years. So T is 5. Okay, so if we put that in, we got A is equal to 10,000. 1 plus R, which is 0.08, divided by N, which is 12, raised to the NT power. So we got 12 times 5. So it gives us 10,000 times 1 plus 0.08 divided by 12. 12 times 5 is 60. Okay, so we got 10,000. Beginning parentheses 1 plus 0.08 divided by 12. Closing parentheses, caret 60. So we got 14,898 and 46 cents. And it looks like they rounded to 15,000, but that's C. Okay, number 4. What approximately is log base 2 of 12? 2 is the closest answer. Now, you could use a calculator for this if you had a TI-3, TI-4, or you're trying to find out what this is equal to. So we set it equal to blank. And blank, well, you could put a variable here. You could put X. So using our definition of log, this would be our B, this would be our Q, and then the other side of the equal is always our P. We could rewrite it in exponential form, which is B to the P is equal to Q. So we'd have 2 to the X power is equal to 12. And from here, if I think about which one's the closest answer, 2 to the first is 2. 2 squared is 4. 2 to the third is 8. And then the last one is 2 to the fourth. Interesting. They said the correct answer is 4, but unless it's just too early in the morning, it looks like to me 12 is halfway in between 8 and 16. So it's a distance of 4 from 8 and a distance of 4 from 16. I would have said actually X is equal to 3 or 4 in that one. Okay. Half-life of carbon-14 is 5,730 years. How old is a bone that has 70% of its original carbon-14, which is the correct answer? Let's see if I can remember the formula for this. 70% of its original carbon-14. And I don't remember the formula, but these variables will do. Okay. half-life of carbon-14 is 5,730 years. So they're giving us T is 5,730. So that's our time. How old is a bone that has 70% of its original carbon-14? Okay, we'll get to that, but the half-life of carbon. Now this A represents the ending amount, and this A sub naught is the beginning amount. Okay, so this is A sub naught, half-life. That means it's got half as much as it originally had. So we put half of A sub naught over here. Because A sub naught is our beginning amount. Now I could solve this. Divide both sides by A sub naught. And when we divide both sides by A sub naught, the A sub naughts cancel. And we get 1/2 is equal to e to the 5,730 k power. Now take natural log of both sides, because we're trying to solve an exponential equation. And whenever you have natural log and e, we talked about up above, they cancel. So that gives us 5,730 k. And divide both sides by 5,730. And that's going to equal 2k. Now I could put that in decimal form. Maybe I will, just make it a little bit easier to see. Natural log of 1/2 divided by 5,730. Now e to the -4 is scientific notation. It means that we're going to have negative point, and I'll move my decimal point 4 places left. 1, 2, 3, 1, 2, 1. That's probably enough. So this equation now becomes A is equal to A naught e to the negative 0.000121 t power. Now we could have left this value in and had the exact value there instead of an approximate, but hopefully 6 decimal places is enough for this problem. Okay. How old is a bone? How old? What is T? That has 70% of its original carbon-14. So they're telling us T 70% means we have 70% of the original amount. So 70% times A sub naught. Now I could divide both sides by A sub naught like I did over here, and we'd end up with 0.70 or 0.7 is equal e to the negative 0.000121 t. Take natural log of both sides. And we get natural log of 0.7. Natural log and e cancel each other, so that's negative 0.000121 t. Then divide both sides by that. And we get natural log of 0.7 divided by negative 0.000121. So natural log of 0.7 close parentheses divided by negative 0.123121. So we get 2,947.7. Approximately 3,000 years. And that'd give us our answer. Okay. Clean this off. And let me make up an example just so it gets it's done. We want to find the zeros of f of x is equal to x to the third minus 3x squared plus 4x minus 12. Okay. Question was, when do you use the p over q in the synthetic division and the quadratic equation? Though I think about the quadratic formula. And whenever it asks you to find the zeros, that's when you do that. Because finding zeros means you're basically setting that equal to 0. So we got x to the third minus 3x squared plus 4x minus 12 equal to 0. And our largest power tells us how many answers we're going to have. So the 3 tells us we're going to have 3 answers. Well, we have to find out all of our possible rational zeros. Our number at the end is going to be our p, and number at the very beginning is our q. Now p is 12. We ignore signs. And we write down all the products give us 12. We've got 1 times 12. Now I'm putting a plus or minus there to account for any signs that might be here. Because a positive 1 times a negative 12 gives you negative 12, and a negative 1 times a negative 1 times a positive 12 gives you negative 12. And we'll have 2 times 6, and we'll have 3 times 4. Now q, there's the invisible 1 here, and the only thing that gives you 1 is 1 times 1, and I put the plus or minus again to account for all the different possibilities. Because you could have negative 1 times negative 1 gives you a positive 1. So all of our possible answers we're going to find by putting each value of p over each value of q. So we'll have 1 over 1, we'll have 2 over 1, we'll have 3 over 1, 4 over 1, 6 over 1, and 12 over 1. Or we got 1, 2, 3, 4, 6, and 12. With a plus minus in front of all of them. Now those are all of our possible rational zeros. So what we're going to do is we're going to take each one of those and plug those into synthetic division based upon our problem. So I got 1, negative 3, 4, negative 12. Remember this was x to the third. So we'll add 1 plus nothing's 1. Multiply. You always multiply by number in a box, by number you put down here. Negative 1 times 1 is negative 1. Add. Negative 3, negative 1 is negative 4. Multiply. You always multiply by number in a box, by number you put down there. Negative 1 times negative 4 is 4. Add. 4 plus 4 is 8. Multiply. Negative 1 times 8 is negative 8. And add. And we get negative 20. Now we're looking for zeros remainder. We haven't found that yet. So that was negative 1. So now we go on to the next possible answer, which is a positive 1, because we got a plus or minus 1. And we'll plug it into synthetic division. Add, multiply, add, multiply, add, multiply, add. Still don't have a 0 here. So we go on to the next one, negative 2. Plug it into synthetic division. And still don't have a 0 there. Okay. So we'll go on to 2. Now you don't try every number, you just try the numbers in your list here. Okay, so going through this one. Still don't have a 0 here. Now next one, negative 3. Okay, so add, multiply, add, multiply, add, multiply, add. Still don't have a 0 here. Let's go to positive 3. And remember, this is x to the third. So add, multiply, add, multiply, add, multiply, add. And notice what we got. We got a zero's remainder. Zero's remainder means you found a factor, or another way that what that means is we found a zero. Now, finding zeros is our goal here, so whatever number's in this box is our first answer. So our first answer is x equals 3. Now, this started out as x to the third. This is now x squared. It'll always be 1 degree lower once you find an answer, once you got a remainder of 0. And once you have your first one, then you have one for each one going down. So this is x squared, this is x, this is our no x, our constant term, and that's our remainder. Now, anything with a 0 you ignore. So we're left with x squared plus 4 is equal to 0. Now I'm going to solve this using the square root property. So I'll take the 4 over, becomes a negative 4. Then square root property says you drop your squared and you put a plus or minus square root around the other side. And negative inside of a square root gives you an I, and 2 times 2 gives you 4, so that gives us x is equal to plus or minus 2i. Now remember how I said we're going to have 3 answers? Well, we had one answer here. And then the plus or minus counts for our other 2 answers. So that's all 3 of our answers. Now, the question may have been, well, how do you decide what technique to use? Your goal is to get it down to the x squared level. Because if you can get down to the x squared level, then you can drop out and you can use another technique. So let me clear that off. Okay, you've done some steps up here. These indicate steps you can't see. You've done through your synthetic division, and you're now at a quadratic state. Quadratic means your highest power is x squared, assuming it's polynomial. Okay, well, then we got different possibilities. One you ask is can it factor? So you ask yourself that question. For example, if I got it down to x squared minus 5x plus 6 equal to 0, I see it would factor. So this would be x minus 2 times x minus 3 equals 0. And then you can use the zero factor property. Zero factor property says you have 0 on one side, you factor the other side, you set each factor equals 0. So I'll set x minus 2 equal to 0 and x minus 3 equal to 0, which will give us 2 and 3. So if it can factor, you can use the zero factor property. Is the middle term missing? Although some of these you can actually use that first technique we looked at. You can factor. But this is like that one we just looked at, where we had an x squared plus 4 equals 0. Our middle term's missing. We don't have the x. Well, we want to get the part that's squared by itself, so you take the 4 over, gives us negative 4. And this is where you can use the square root property. Square root property says you drop the squared and you put a plus or minus square root on the other side. And we've already talked about this problem, so I won't go into detail, but that's how you'd solve that then. Now, none of the rest. You cannot factor it, and the middle term's not missing. Then if you have x squared plus x plus 3, for example, equal to 0. Doesn't factor. The middle term is not missing. This is where you use the quadratic formula. Now you have to have 0 on one side, and if you do, then you identify your a, b, and c. A is whatever's in front of your x squared, which is 1. B is whatever's in front of your x, which is 1. And C is your number at the end, the constant term, which is 3. And we got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So we'd have negative 1 plus or minus square root of 1 squared minus 4 times a, which is 1, times c, which is 3, all over 2a, so 2 times 1. And that gives us negative 1 plus or minus square root of 1 minus 12 over 2, which gives us negative 1 plus or minus square root of negative 11 over 2. Now remember, a negative inside of a square root gives you an I, so that's negative 1 plus or minus I squared 11 over 2. And then to write it in standard form, you separate the real part from the imaginary. So this would be negative 1/2 plus or minus squared 11 over 2 with an I to the side. So once you've gone through your synthetic division process that we looked at in that previous example, and you get down to the quadratic, those are your 3 possibilities, your 3 choices on how to continue the problem from there.